Hi class, I'm here today to talk to you about problem number 3 from lesson 3.5 worksheet prediction and accuracy. Problem number 3 involves some data, and that data looks like this. It tells you on the left side, they give you the school year, and on the right side, the number of students enrolled in public school for those years. Now, it's my assumption, and I did look this up online, that these data items that you see over here, okay, that's not 17,000 students. To me, that is 17 million students enrolled in public schools. When you get down to 1999 to 2000, 46,812, that's way under the number of students that were enrolled in public schools. Perhaps they mean 46,812,000. That seems a little more likely. Okay, anyway, after clearing that up, the other thing we need to clear up is that the school year, I'm going to input those into my calculator as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Instead of actually putting in the year number, I'm putting in 1 would represent 10 years since 1900. 2 would represent 2 decades or 20 years since 1900. So when I get down to the year 2000, my number will be 10 for 10 decades after the year 1900. Okay? So those are the values I'm going to use for list 1. For list 2, you're going to have, as you can see here in stat edit, list 2 is just the number of students. Go ahead and put those numbers into your calculator as I have them on the screen. Please be sure to go all the way down to year 10, where we had 46,812. Next, let's go to stat calculate median, where you can see I have here median, hit enter, it'll give us the median line of 2867.6 will be our slope, and 15,407.4 will be our y-intercept. Let's go ahead and write that down on our paper so we don't forget it. So we'll have a y-hat equation. Remember what y-hat is. Y-hat is our estimated value using our median line, and it is 15,407.4 plus the slope 2867.6x. So that's our median line, and we're going to use that to predict the future. Now, what I'm going to do is I'm going to do everything from here on out right on the calculator. This is a good technique for those of you who don't like to jot a bunch of stuff down. Do everything right on the calculator, right in your lists. So let's go back to stat edit, and let's go over to list 3. Let's have list 3 automatically calculate the predicted values using our line of best fit. To do this, you can see that I have scrolled over to list 3, and then I scrolled up so that I'm right on the header for list 3. Now I'm going to just type in my equation, 15,407.4 plus 2867.6, and I want it to multiply the slope times the year that I have in list 1. So I need to tell it to multiply by second 1. See how it automatically puts list 1 in there? When you hit enter, it automatically calculates every single y-hat value for this data. Nice, huh? You don't have to punch it in 10 different times. Let the calculator do some of the work for you. Speaking of that, part B wants us to calculate the residuals. So rather than typing in list 2 minus list 3, list 2 minus list 3, 25,678 minus 24,010, rather than typing that in 10 times, we can actually just go over to list 4, scroll up to list 4. This will save you so much time on our next quiz when we get to this stuff. Scroll over to list 4 and tell the calculator to do the subtracting for you. Tell it, right on top of the header there for list 4, tell it to take second L2, so that's second 2, minus second L3. and it'll calculate every single residual for every single point by the power of hitting enter. Boom, there they are. All the residuals for every single data item. Now, they want us to, I'm not even going to write those down. I have them in my calculator. I'm not going to waste time writing them down for part B. The next part is step C. Calculate the mean square error for the median line. Now, as you know from class, we basically take that phrase, root mean square error, and work backwards. We find the error, then we square those errors, then we find the mean of those squares, and then we square root. And that gives us the root mean square error that we're going to find. So again, let's let the calculator do the work. We found all the errors because the residuals are the errors. They are currently housed in list 4. We next want to square list 4. So let's go ahead and do that. Let's let the calculator do the work. Go over to list 5. Go up to the top, right where it says L5, and type in, calculator, please do this work for me. Second list 4 squared. It will take every data item in list 4 and square it. Enter. Boom, there they are. All of the data items from list 4 are now squared. We're halfway home in the root mean square error. The next thing we need to do is go to second quit. We're on a blank screen, and what we want the calculator to do is we want it to now find the sum of all those squares from list 5. There is a built-in feature here that you may not know of. There's something on the calculator called the catalog. Press second 0, and that pulls up the catalog of everything the calculator can do. We want it to find the sum of everything in list 5. Right now, if you notice on the calculator, it says that we are now, right up here, it says we're on the alpha keys. And the alpha keys are A, B, C, D, E, F, G, etc., what you see in green on the screen. I want to go down to S. It'll jump down to the S's if I press the LN button. Hopefully you saw it highlight there in purple. Here it was again. The LN button will take me down to the S's. We want to scroll down from the sum. Pretty far down there. You can get there faster by going to T's and scrolling up. There we go. Sum, S-U-M. Once you find sum, press enter. It's now waiting. What do you want it to take the sum of? We want it to find the sum of list 5. Second, L5. You can close the parentheses and hit enter. The calculator added up every one of those squares from list 5. Now that's not it for finding the mean. We know from class that the mean portion of the root mean square error actually finds the sum of all of those differences squared and divides by n minus 2. Very important there, the n minus 2. N minus 2 in this case, since there are 10 data points, would be 8. So all we need to do at this point is we have all of our squares added together. We divide by 8. Enter. We're not quite home free yet because it's called the root mean square error. So the final step in the process would be to take the second square root of my second answer. So it'll take the square root of the previous answer, and there we go. 4380, or rounding up because of the 0.99, 4381. The root mean square error in this problem is 4,381 students. They want the real-world meaning of that root mean square error. Well, that means this. If we predict out to the future how many students will be enrolled in the year 2020, the year 2030, that prediction may be off by either 4,381 students above or below that prediction. That's one indicator that we can use in statistics, the root mean square error. It tells us how far the data might be off. Okay? Finally, in Part E, they want us to see how accurate the World Almanac's prediction is for the year 2013-2014 school year. 49,737 students are predicted. Now, let's treat that as our Y. That's an actual data point. Okay? 49,737. Let's use our equation to find Y hat. So the Y hat will be the value that we get in our equation by plugging in, drum roll please, what value should we plug in for X if we want the year 2014? Let's think about this. I would put in 8 to represent 1980. I would put in 9 to represent 1990. I would put in 10 to represent 2010. For the year 2000, I would put in 10. For the year 2010, X would actually be 11. It would be 11 decades past the beginning. For the year 2020, I would put in 12. So for the year 2014, I'm going to actually plug in an X value of 11.4. I'm going to put 11.4 for the year 2014. Please ask me about that or post on the discussion about that if you're not quite sure why I'm using 11.4. But from here, we just take our equation, which is 15407.4 plus 2867.6 times 11.4 to get the predicted value for the year 2014. Sorry, I messed up there. Let's go back, hit second enter to pull that up. That was clearly way off. I put in 111.4. Back up and delete one of those ones there. Enter. That looks a little bit better. According to our median line, we would be at about 48,098 students. Let's clear some of this up a little bit. Okay. 48,098. That's going to be my Y hat. My Y was 49,737. So they want us to calculate the residual. So I need to do 49,737. That's my Y. 49,737 minus my previous answer, 48,098. So our data is off by approximately 1,639 students. So the residual, let me use a different pen there. The residual is 1,639 students. That concludes my going over of problem number 3 from the 3.5 worksheet. Any questions or comments, just go ahead and post on the wiki or let me know on Monday. Thanks.